Algebra 2, Chapter 1.4, Exercises 11 through 18. In this video lesson, we're going to go over the odd number problems 11, 13, 15, and 17, and leave it to the viewer to do the remainder of the problems. For the given function, determine the domain of the inverse function, then find an equation for the inverse function and graph it. Interpret the meaning of the inverse function. Well, we have geometry. The equation A equals 1/2 times 20h gives the area A in square inches of the triangle with a base of 20 inches as a function of its height in inches. So what we're going to do here is, for an inverse function, we're going to take this variable right here, h, and we're going to solve for h. And once we solve for h, we're going to have the independent variable be a, and so we're going to isolate h. So the first thing I'm going to do is just kind of simplify on the right side. We have 1/2 of 20. 1/2 of 20 is 10. And then continuing to solve for h, if we divide both sides of this equation by 10, we have h is equal to a over 10, or you can write it as h is equal to 1/10 a. And these would be our inverse functions. Okay, so let me just write this out. So I'm just going to put it like this. I'll just say inverse function. And we are asked to graph the function. Okay, so we have h equals 1/10 a, and so we're using our area, and the slope is 1/10, so that means up 1. I'm going to do is I'm going to go up 10 and then right to 100. So here's 100. So up 10 over 100. So we'll be going right here. So the graph is going to look like this. Let me see if I can draw it a little more accurately. It's hard to get these things right. Come right up through here. So right here. So it'll be this type of relationship here. So there it is. And interpret the meaning of the inverse function. Okay, input. We can now, the meaning would be with the inverse function, we can use area A to find height. So we've switched the independent-dependent variable situation. And what else do we have? Then find the domain of the inverse function. Well, the inverse, or domain, And I like to use interval notation. So we have to have a value of, and you can use a bracket or parentheses. I'm actually going to use a parentheses, and I'll tell you why in a second. We can go from 0 to as large of a area as we want. And the reason I'm using this parentheses is because we don't truly have an area until we're greater than 0. So that'd be the distinction there. So here we have our functions. So that's it. Okay, next odd number problem we're going to look at is number 13. The graph of function is given. Tell whether the function's inverse is a function and explain your reasoning. If the inverse is not a function, tell how you can restrict the domain of the function so that its inverse is a function. Well, you might remember that for a test of function being a vertical line test, to test if a function has an inverse of a function, we use something called the horizontal line test. And what we do is you create a horizontal line like this one here I'm doing in green, and then you can take that line and you bring it up, and if the horizontal line touches the graph of the function in more than one place, we say that this function fails the horizontal line test, which means that if we turn this function sideways and take its inverse, which is going to look something like this. Okay, I'm drawing now in blue its inverse. See, its inverse is not a function, because the inverse will fail the vertical line test. So what we're going to do now is, let's see, inverse is a function. So no inverse, and we're going to call it f -1 of x. That's inverse function notation, is not a function. And what we do for this is we say not one-to-one. And if you look at down here below at 14, I think you find a one-to-one function there. Anyway, how can you restrict its domain is the next thing they ask. Well, to restrict domain, if we just take pieces of this function where it is one-to-one, then we'll have the inverse of that piece will be a function. So if we restrict domain to negative infinity to x equals 0, I guess I'll put parentheses here, or 0 to infinity, or any subset of each of those, of each interval their inverses would be functions, or are functions. So what we have here, let's say we just take this piece from negative infinity to 0. We have this piece right here. Well, its inverse is going to be just simply flipped across the x-axis. So I'm drawing the inverse of that piece in green. So these are inverses of each other. They are reflections about this line y equals x. Okay, so that's number 13. Next, we're going to look at number 15. Identify the domain intervals over which the inverse of the graph function is also a function. Select all that apply. This really is like number 13. We look at the piece. We look at if that piece of this function, we talked about the horizontal line test, if the piece of the function defined will also pass the horizontal line test, then we'd have a function. So we can look at A, for instance, where we have the interval between 4 and positive infinity. So I'm going to trace over that interval between x equals 4 and positive infinity. So just the piece I drew in blue. Okay, now is there an inverse of this piece of that function? Yes, there is. And the inverse is going to be right up here. Okay. So this piece I just drew up above is the inverse of the original piece, which is the domain between 4 and positive infinity. So that is correct. Let's see. B, between 0 and to infinity. Well, here 0, we have this piece here, and 0 to infinity, this piece here does not pass the horizontal line test right here, because the horizontal line touches twice. So B is not right. C, between -4 to infinity, no, same reason, because we have this piece here in addition to that other piece. D, between -infinity and infinity, no, because we failed the horizontal line test. Between -infinity to 4, well, here's -infinity to 4, -infinity to 4 to x equals 4. And does it say including? Well, here's it's a little tricky with this bracket. It kind of ruins things for us, because that brings in this point right here because of the bracket. Well, this point here alone, if we didn't have that point, the horizontal line test would pass, but we have that point, so it does not pass. Next, look at E. Okay, you have, or F, you have -infinity to 4, but parentheses. So that means this point is excluded, and that means for this one here, for case F, the horizontal line test works, and the inverse of that particular interval is a function. Next, for G, 4 to 8, well, 4 to 8 is just this piece right here. And so that has an inverse. That's a 1 to 1 all the way. So G is correct. H between 8 to positive infinity. Well, 8 is a subset, okay, that's a subset of this 4 to, it's a subset of really, it's sort of the other end of what, I guess it's a subset of, this H is a subset of choice A, right? So that's correct. And between 0 to 8, no, 0 to 8 has these two pieces here, here, and here. So that does not apply. So these are the ones that are circled, have inverses. Next, 17. Make a conjecture. Among linear functions, excluding constant functions, quadratic functions, absolute value functions, and exponential functions, which types of function do you have to restrict the domain for the inverse to be a function? Well, I'm just going to go ahead and sketch what they look like. Okay, so if we have there's one, a linear function. So I'm going to go ahead and sketch the graph of a linear function. Alright. What else? Quadratic functions. So we draw a quadratic function here. That's going to look something like this. And what else does it say? Absolute value functions is going to look like this. So it's going to look something like this. That's an absolute value function. And finally, what do they say here? Exponential functions. I'll leave a little more room here like this. Exponential function is going to start like this and go up like this. Okay, what you're looking for is the if we look at, I'm going to draw a horizontal line, and if we take this horizontal line and move it over here, so for the linear function passes the horizontal line test, for quadratic function does not, for absolute value function does not, is not 1 to 1, for exponential function does. So in this one we have to restrict, let me go ahead and erase this. Okay, we need to restrict quadratic and absolute value function and why do we have to do that? Because they are not one-to-one. Or you could say alternatively that they fail the horizontal line test. So that would be our answer to that one. And then I'll just turn to 18, find the error. So 18 is the find the error problem. So that's the extent of what I'm covering in this video lesson today. I hope this has been helpful to you. Good luck, and thanks for viewing.